Hello everyone, welcome to Push Systems, Kanban here at Columbia Aircraft, and this is a simple use one, make one approach to downstream replenishment. What we're going to use here is a standard here at Columbia. Now my name is Ross Buell, and I'm a manufacturing planner, and you can find me sitting across from Chris Redgrave's office. I've been here for about 4 years, just over, and I'm the guy who's going to be teaching your class today. Now this is going to be the general 10,000 foot look level at our standard Kanban process here at Columbia. So it'll give us the same terminology, what to expect when you look in different departments to see what they may be using for their Kanban system. Now each department will have its own nuances, and therefore we can determine that offline with those departments. So we're not taking everyone's time, but we just want to make sure that we get everyone a basic foundation of where they need to be. Give you a brief explanation of Kanban here. Basically, the word Kanban is a combination of card or signal, and it is basically referring to or defined as an implementation technique for a demand pull system referred to as a trigger. Now a trigger is anything that tells someone to make a part. It gives them the authority to make a part. So it could be a card, it could be an empty bin that is turned into inventory, it could be a monkey with a flag. It really doesn't matter as long as you got something that says you get to make a part right now. That's all it is. Now the Japanese methodology did become popular here in the US in about the 1970s, but it was not a Japanese invention. There's been a lot of people who can be credited with coming up with lean manufacturing, but the Japanese are the ones who really ran with it once they got involved with that process. Well, one of the first people who actually came up with this, his name was Frank Deming, and he first introduced the lean concept to the American automotive industry back after World War II. But since they were the economic superpower for the automotive industry at the time, they were like, no, okay, that's okay, thanks a lot, bye. Japan, on the other hand, after World War II, was very, very motivated to rebuild their economy and get their manufacturing processes back on track. So they took this on with much gusto, and they ran with it. And it's evolved since then, and then now we have kind of what you see us implementing here today. Now here at Columbia, we first introduced a Kanban system back in 2003 in a composite shop. And it has evolved since then to include just about every aspect of the company. And even today, we're involving more parts and getting more things into our process, so the whole thing will run smoothly. We're chasing MRP out of the interior of the factory and leaving it to control the stuff that's outside. And we'll get into that a little more here in a minute. Now, Kanban is a just-in-time process, and it basically means when your customer uses a part, you can see that that part is now vacant, the location where it's at, and you will build one to replace it. So you supply it just when they need it, just in time. Any questions on that? Now, why do we want to use Kanban rather than our MRP system? Now, it's a system that works for a lot of people, and it is a proven way to do things, but Kanban is a pull system. And in pull production, it gives a signal or authority to produce a part based on the demand of that material from your customer. So they are pulling from you what they need. You don't want people pushing parts on them, and we'll go into that here in a little bit too. But material requirement planning is a push system. And in push production, you have to anticipate what you're going to be needing in the next week, month, whatever, your quarter, and try to guesstimate on how much you need to buy, what you need to supply to be able to meet this requirement that you're going to be producing. The problem with that is guesstimating. You can't see the future. You can't tell what may be happening. And what if we change our production rate? We change our schedule. It can't react very well with that. And MRP is a push system. Why do we use Kanban? Well, first of all, I'll go into two separate things on this. It eliminates waste. And we have two types of waste that I'm going to go into now, but one is overproduction. We don't want people producing more than our Kanban requirements. And the reason for that is if we have so many parts that we need, but we continue to produce. We're wasting resources and producing more than we need. That could be used elsewhere where it would be more valuable to us. We also, by eliminating overproduction, we will have more space on the floor, more space on our shelving to put the things that we need. And if you have any questions about space that's needed on the floor, try walking from the composite shop, weaving through wings and crawling through fuselages to try to get to the lunchroom. Kanban will eliminate that traffic jam that we have in there. So that is one resource that we very badly need. Now, Kanban does require less planning on the production floor. It is self-regulating, although we have to continuously improve it and continuously modify it to meet our needs. Kanban is not a just start it and forget about it type of system. Now, there's two processes that we've used in the past that we need to actually integrate into our Kanban system and think of them as part of the system, not just some separate thing that we do. And that's 5S and Kaizen. 5S, and there's I think on the back page or second to last page of your handout there, is just a breakdown of what 5S is, but I'm going to go into it here as well. First is sort, the first step in an organization. Second is set and order. Organize, identify, and arrange everything in order. Shine, regular cleaning and maintenance. Standardize, make it easy to maintain. Sustain, maintaining what has been accomplished. If we do these, we can make our Kanban system also sustainable, maintainable, and easy to use. And everyone will have the same thing no matter what department they go into and know how to use it and see what's happening. Now, Kaizen literally means continuous improvement by small suggestions. And Toyota is one of the first people to implement this into their processes. And they get an average of, say, 5 suggestions per employee per month that produces in Toyota. Automotive, everything else that they make. You can average that out to about 60 suggestions a year per employee. So you can kind of guess how many suggestions a year they get from their entire facility. There's a lot of stuff coming in. They can probably do quite a bit of good with their processes just by what the people, the experts on the floor, are suggesting for their processes. Kanban also creates a clear visual indicator of what is needed down the line. When your customer has a buffer of 5, they have 5 parts in their area. When they use one, they're going to send a card back and tell people to produce that part. So this spot is now empty. So you can look and say, oh, now I need to produce another part. You don't have to have them come tell you. You don't have to debate about it, think about it. It's right there. It's either all or nothing. You make it or you don't. Any questions on that? MRP and pig swallowing. This is the problem with push production systems. After you swallow your pig, what do you do with it? What this represents is our snake here is our factory. Our pig here is our raw material. And this represents the wet. Our snake, our process moving through. And this is an inventory bubble. Now, how long do you think you're going to have to sit here and wait before you get your final product from your snake for this to come through the process? We don't want to run Columbia like this. We want to leave the pig swallowing to the experts, the snakes. We want to have a more manageable, more on-time process and smaller, more manageable amounts that will give us better results and better timing for what we're producing. Yeah, it's a common problem with push systems. Constrictor snakes are designed to process meals in a particular manner, and they often sleep for months after they eat their meal. Yeah, we don't want to wait months for our parts to come through. Not literally months, but we don't want big time gaps between each time we get a release of parts to keep the guys working. Or we will have people sitting there waiting for parts to come through in the process before they can go to work. Now, the authors of Running Today's Factory, a proven strategy for managing manufacturing, uses the pig and a python as an analogy for inventory bubbles, just as I've shown here. Now, the problem with this is we can create these bubbles using our Kanban system by not following our requirements on our Kanban card, by batching our parts. I'm going to pick on Trim Shop a little bit. They have a fixture that they have to set up. So it's easier for them to set up one time and produce 10 parts than it is to go and look at their Kanban card that tells them to make 2. Well, yeah, I can make 2, but I have to go through and set up my fixture again next time, So they decide to batch. But by doing so, they're going to create this bubble through the process, and they're going to make the process fail for everyone else down the line to know. So it's very, very important that they stick to their processes. So, Kanban manages the bites. If we had smaller piglets coming through our process, you're going to get smaller amounts more often that you can manage and be able to take care of and have a more timely manner of your process running through. You can control that better. And if you have a batch, say that is NCR, there's something wrong with it, you don't have to wait as long for that next big batch to come through. You have another batch coming through sooner rather than later to replace that problem. Any questions? Okay, signals. A signal, like I said earlier, is just something that tells you to produce a part. These are the common things that you're going to find for signals here at Columbia, but it could be anything. Primarily we use Kanban cards, we have work order cover sheets, and we use bins. We can also use bags and different things to tell us when we need to purchase more parts. Kanban cards. There is a basic layout that you're going to find on the card. Although the cards may look a little bit differently between departments, you're going to find similar information on them. Where it's coming from. This card here shows that our supplier, where it's coming from, is fuselage trim. Now it's going to go to the customer, where it's going to, which is fuselage bond. Next, we'll have our part number, it tells us what part this card is regulating. And then we'll have our oven run number, our quantity required, location, and description. Now, if you look at these cards, and there's some examples on there, this says WO for work order. We used to have a 3-digit system that controlled our numbering process on our work orders. We didn't rely on the part number itself. So in our oven, we typed in that 3-digit number. In this case, it's 76, so it would have been 076. Now, when we changed over to the part number, our oven could not accept that many digits in the number. So we retained the old 3-digit number for identifying parts during the oven run system. So even though this says work order, it's actually our oven run number. So if you ever run across that and wonder what's going on, that's what's happening. Now we also have our quantity required. This card authorizes them to make one part only, no more. The location of this finished part will be found in inventory, and it's F2D1. That's where you would go to find this part. Now we have our description here as well. And in this case, it's a Nacaduct fresh air intake. I need a remote control for this. The picture, you will also have a picture or an identifying symbol. This here is a picture of the Nacaduct itself. Now we also, for different departments, have a little paintbrush on it for the paint department, or a little airplane with a circle around it for sub-assembly. And the reason for this is so you can group parts and cards from a distance and know what they are without having to get right up and read them. You have a quick reference of what's happening. Underneath the picture, we have a routing info. It tells the people who's producing the part where to take it. And then at the bottom, we have a description and the part number again. Now the reason for that is if we have 5 parts in the Kanban, you can stagger the cards on top of each other and take up space and still see what each card is representing. Now also, our cards are color-coded. We have white for outsourced layup, purple is layup, and that's the general color of your card. Gold is for bond, green is paint, blue is upholstery, orange is inventory, and peach is the new card that you'll find out here on sub-assembly, on the assembly line. All right, moving on. Bins. Bins are used for handling hardware. We use them all over the facility. Basically, we could have a 2-bin system where you have 2 bins or bags or any 2 type of containers that will hold the same part. So you have the same screw, same part number. When you have the 2 bins, you use up the parts out of your first bin, turn it into inventory. They will refill your part while your guy comes back and works in the second bin. So there's no downtime for them waiting for parts to come back from inventory. We're not doing this. They have a place to pull from and to work from while inventory delivers this back. And when this full bin comes back, it takes a second position and they finish off the first one and keep going. We're actually not using this very often currently in here, but now that we are giving the class, we're setting the standard, and they're getting that in place. Also, it's hard to see, but I was talking about signals earlier. Inventory put a red little clip on here. This is actually a Kanban system. It's a signal telling them this bin is low and it needs refilled. So it's not quite as good as a 2-bin system, but if we don't have 2 bins, this works. I think the person responsible is sitting on here. Now we have cover sheets. They remove a cover sheet from the work order, turn it in, and that tells Allie in production control to produce a new work order. These cover sheets do not regulate the production of parts. I'm going to pick on avionics again. They would get a work order in, they had this sheet on it, they went, ooh, Kanban sheet. They ripped it off, turned it in, made the part. Then another work order came back because this told production control to make one. Rip it off, put it in the return box, and made the part. They thought this told them to make the part. All this does is tell production control to replace the work order with a current version of that work order. So, because avionics did not have a current Kanban system set up, we have 30 harnesses of one type for one aircraft a week pouring out of the shelving there in avionics because they did not know they needed to stop producing. These sheets only replace work orders. They do not make parts. The only things that tell them to make parts are our cards on the post, and that has since been rectified. But yeah, if you go into the avionics department right now, you'll see we have a huge backlog of parts in there, and that's money that could have been used elsewhere. So that's why the Kanban system is so important to regulate what we produce, because it will save us money and allow our resources to go other places. Now this has been affectionately referred to as my TPS report. If you've seen the Office Space, you might know what I'm talking about. But this is basically what I wanted this to show, and Toyota's a little bit different than we are, but it shows that these are cycles in each department. You have your customer, or your supplier, you, and then your customer. Your supplier is going to produce a part when they get a card telling them to do so, and they will deliver it to your IPK, or your location that you store your raw material in. When you pull that, the card goes back and tells them to produce another one. Now you will go through, you will do your work, and when you put it to your customer's IPK, when they pull it, the card goes back here and tells them to pull another card right through. Do you see how it's just a cycle that continuously follows through the process? And I can show that in another way right here. I love the process. I cheated a little bit here. This is my post, or the place that I keep the cards that tells me what to produce. And I make staplers. Better yet, I add staples to staplers when I take down a production line. This is my IPK location, and this is the Kanban card that came with my raw material. So when I pull this part to work on it, I send this back to my supplier, tells them to bring me another stapler. Now I come in here and I do my work, and I get my staplers out, and I drop them in, and now my work is complete. I pull my card, I send it with my part to their IPK location. And when they pull that, they will bring it back to me and set it on my post. Now, if they don't pull it, I have nothing here indicating me to produce anything more. So I don't. Now, these guys might send me another stapler, but I can't pull anything here until I get told to do so from this point. That's how it becomes a pull system. You have to have something up here beyond you pulling it to them. And until that happens, you don't have authority to produce a new part. Any questions on that? If you guys stand up and stretch in a second.
No, we won't be done for naps soon enough. Don't worry about it.
Post and color coding. What a post gives us is a place that's a centralized area in each department, and it helps us set the priority of the part and how many parts we need in one location for our technicians to look and see what they need to produce. It is a cycle, but I chose the post to be the beginning of our process, just so we can track it through the system and see how it works. Now, They are used by the supplier to authorize the production of a new part. They also set the priority of that part by the color of the field that the card is placed in. I'm going to kill the lights for just a second so you guys can see the colors a little better here.
Dangerous.
Yeah, I know, but I pull stuff. Okay, now we have the green field, and I hope you can see this here. See our top bar here is green? That is when you have one card, or you're required to produce one part. You don't have any requirement to go beyond that. So that card would be placed here. Now we have the yellow field, and that means extra attention is needed. So you have a requirement of 2 or 3 parts that you need to produce. What this means, though, is you have one part that had a requirement of 1, and then you had 2 more cards come in. This card does not stay in green. They are all now an extra attention needed priority, and they all move to this field. Make sense? The red is the same thing. It has a urgent requirement, and when that comes in, any cards that you had in the yellow also move up to the red. The reason for that is, in green you have 4 parts on the floor that are available for people to use. In yellow, you could have 2 or 3 parts that are available. Red, they have nothing. They need it now. You also, because you have 4 parts here, possibly 2 or 3 parts here, you have time to get these knocked out before these become an urgent priority. Now Kanban, it will take a little time, but while they're working on this, another one could move into the red. Well, they got to knock that one out at that time. But what this will do is self-regulate, and eventually to keep on top of it and keep the system working the way it's supposed to, all this stuff will be in the green, and it will clean itself out. Any questions on that? Guess I'm going to turn the lights on before everybody goes to sleep. Oh.
Can't believe we're going to do that row. What was that?
Now bags. A bag is another form of a Kanban post. And we use them because you can't use a post in every area of the composite shop. There just isn't space. So they will take a bag, place the card with the work order inside. In this case, you can kind of see the little rib here. This part will fit in the bag. If it doesn't, the part would be clipped to the raw material on a rack as they bring it through. Now the reason we want to do that is we still need to set the priority of the parts. Now a clear bag means the same thing as the green field on our post, a normal standard. Now the yellow means extra attention is needed, and red is urgent. Now here's the downside of this system compared to a post. At the point of conception of the needed part, we will put the work order in the Kanban card in its bag, clip it to it, and send it out. We can't update that. So after it's out, it's whatever priority the bag is. But say we get 2 more requirements after that part has gone out. Those are yellow. Well, they can't exactly go out and necessarily find that other part in its process to change bags on it. So it gives us a way to determine the priority of the parts, but it's not as real time as a board post is. But it's better than nothing. Any questions? You guys made me nervous, you're so quiet. IPK, or in-process Kanban. This is basically just where you put your part when you produced it, or where you pull your part from in your area. Each part will have a Kanban card attached, as you can see here. We have 4 baffles here, and each one's got its own card. And this area that it's sitting in is its IPK. What that means is someone can walk up and look and say, no, we have normally 5 parts in the Kanban process. There's only 4 here. The other card, you can automatically assume, is back at the supplier telling them to produce 1 part. It's automatic, that's how it works. Now our material handlers, or water striders, are the people who's going to be responsible for moving these parts into the locations from one department to another. And so they will be keeping an eye on this stuff to make sure everything's working right. And they're the ones who raise the flag if any problems come up in the future, so we can address it immediately and get it fixed. Kanban card bins. That's where they put the card. You know, when I pull my stapler, I pull the card off and I use it. I place this card in the bin. This gives a centralized location for our water strider to pull the cards from, so they don't have to look all over the place. And each department is going to be set up the same way. Now, this is kind of a neat tool for leads because they can walk up to the bin before it's picked up by a strider and look in here and see, what did my people produce today? What are they focusing on? Are they following the priorities on my post? And so they can get a quick daily update of how their department is performing just by looking in that box. So it's very useful in that aspect too. Now, problems in Kanban, and it's almost requirements in Kanban because it's very finicky in how we use it. A successful Kanban system requires stable processes. It requires us to provide material into it consistently. We have to keep the screws coming in. We have to keep the glass coming in. We have to keep everything right when they need it there at that time. And I see a few eyebrows raised on that. Adhering to Kanban card signal requirements is necessary to make it work. They can't batch. They got to stick to these requirements on the card. This says 2. Don't make no more than 2. This tells them where to send it. Don't send it anywhere else. It's got to go to this place and this place only. Kitting and batching beyond the card instruction will cause the system to fail. It'll crash. It can't handle it. It's very, very finicky. It will not do anything other than what the card says. Other than that, you're toast. It won't work. Also, Kanban does not mean consumable. And what I mean by consumable part here in Columbia is we have some parts that we don't trace the ID. They're below a certain cost, like hardware. People can go up, grab the parts, take it to their area, and they can use them as they need. And what I mean by consumable in Kanban is, let's say the detail department has a panel that they ran a drill through, and they need to get a new panel. So they bebop over to station 2, they grab one of the panels out of their Kanban location and go back over. Can't do that. First of all, the Kanban location in that station is their private property. No one can trespass in there without an NCR and production control involvement, so we can make sure that our processes are adhered to correctly. We don't want guys just grabbing stuff and running because that will throw our system off as well. So we have to get people involved to make sure that our NCR processes are stuck to. And we want to do that because we need to identify problems that could be consistent, and that way we can attack it and get it knocked out. Kanban is not a fire and forget system. We have to continuously Kaizen and 5S the process because it is a living organism. We have to continuously feed it and take care of it to make sure it works correctly. Any questions? Critical rules. The customer must stick to the requirements on their card. Don't supply any more to your customer than they're supposed to. Don't push it out way other than what this requires. It will create an inventory bubble. The supplier, same thing. You don't want to create an inventory bubble for your customer. They can't swallow it. They're not able to do that. They got to be able to stick to their own processes as well. Nothing is produced or transferred without a Kanban card signal. That's what gives you authority to make a part. Like with the stapler, if there's no card on that post right there, I can't move it on, I can't produce anything, because they're not ready for it, they have nowhere to put it. Now, rules continue. All parts and materials will always have a Kanban attached. If there's no Kanban card attached to the part, you got to say why. Is it NCR? Is something wrong with it? Why isn't this in our system? So we have to get people to look at this and find out what's going on, because we can't just move a part through there without being in our system. It'll throw everything else off. So it's got to have the Kanban card attached to it at all times. NCR parts and incorrect amounts never go to your customer. If the part is NCR, it is not complete. There's something wrong with it. If the quantities that are required are not all there, it's not complete. You don't send problems to your customer. They need a complete, ready part to go. So the stuff does not continue on until the requirements of our card is met. Now this one raises a few eyebrows with people, and the number of Kanban is reduced carefully to lower inventories and reveal problems. What they mean by lowering the Kanban is the buffer that each department would have to try to figure out what the problems are. Well, why would we want to do that? Why do we want to create problems for ourselves? Well, like now, we're producing 1 aircraft a week. We have a little bit of time and we have some resources to go out and pick our fights. So, say our baffling that I showed in here earlier. What if we had a buffer of 10? But every third part that we get from our supplier fails. It's NCR and gets scrapped. Well, we have a buffer of 10, big deal, so what? That doesn't hurt us any. We can absorb that and keep working without feeling it. So now is the best time to drop that buffer down to 5. Now we're going to feel that third one a little more every time. Now we can get a team in there to find out why this part is failing, why we have such a consistent loss, and we can get this fixed. Now the reason for that is before we had the money, time, and resources tied up in 10 parts on the buffer, and now we've cut that in half by going through this process. Now we have that much money to move toward the next part to free that up, and so forth and so on. And if you do this with 10 parts, 20 parts, and 100 parts, guess how much money that's going to free up that we can pay our vendors to keep our supplies coming in on a more consistent basis. That's why we want to do this. Picture this. Kanban is being referred to as a rope that pulls the production line along. Chris Redgrave stated that you stand at the gray door, you got the rope, and you give it a good tug, and everything throughout the factory will come along with it. I agree, it is that, but it's more than that. It's a chain. It's only as strong as its weakest link, and if anyone in a particular process does not perform the way they're supposed to, they're going to snap that chain, and everything's not going to pull like it's supposed to. That's why we've got to adhere to these policies and procedures devoutly, almost religiously, to make this thing work. And by doing so, this will clean up our process. It will free up our money and will make us more efficient. And we will have these resources now that we didn't realize we had before. They're here. We just didn't realize we had it. And we can make better use of all our time and money. Any questions?